192.168.1.0. The entire network segment is outgoing from interface 1. So the routing table is written slightly smaller. Write 192.168.1.0. Such a network segment. Just go out from port 1. As 4.3. Point 4. Point 5. No need to write. Because as long as it matches, it belongs to this network segment. Sent directly from port 1. You can take the overall appearance. Become smaller. This is what it means for network addresses. It can replace a whole set of addresses with a single address. Used to save routing table size. A company's internal network. Just these devices. Dozens or hundreds. Routing table is too big. 4 operators. Where does the data go? It can reach billions of addresses around the world. Does the operator have to go to a separate deposit? Does each routing table have billions of routes? This is of course impossible. So, we must optimize it. So we usually take the network segment instead of an exact IP address. Talk here. The classification of IP addresses is finished. Next, we're about to think about a new question. We can see, for Class A addresses, it now has fewer network segments. But there are many hosts available. That means that a Class A address is good. Suppose IANA is an organization. Really assigns a Class A address to our country. For example, gives 1.0.0.08. 16 million plus addresses. That sounds great. So many addresses. If this address is really divided, that's every device in our country is configured. From 1.0.0.1 to 1.255.255.254. This is the range of addresses that can be used. If I make a division, the entire range can be paired. If both match, then, by default, according to the principle, logically it works. Because it complies with communication standards. But if you say that one address is connected, does our business allow it? Over 16 million addresses in total. For our whole country. Is the business allowed? For example, some government agencies. Or some banks. Some securities companies. This more sensitive unit also includes some companies in a competitive relationship. Everyone is on the same network segment. Can access each other anytime. Anywhere. We don't have any control. Nationwide. Do you think this is appropriate? Okay. This is inappropriate. It's very unsafe. First of all, the privacy of the address is not guaranteed. Because everyone is on the same network segment. So, when we use addresses, only use the specified Class A, Class B, Class C. They have corresponding disadvantages. That is, when we are assigning addresses, it will be more difficult. And we have to think about a problem. If now, when the entire country is an address segment, don't be afraid of not being enough. May also be multiple address segments. But each is such a large address segment. You will find, if someone in this address segment sends a data, I need to find a person in the whole network segment. It's very difficult. For example, there are now more than 1,600 people. Assume one device per person. In this address segment, I'm going to find one of these people now. It's too big. So very difficult. And everyone should know. We will learn a message in the future. Is a broadcast packet, called ARP. Such an address resolution protocol. Then when it does the request, it sends a broadcast packet. Based on the current Ethernet networking, we have to use ARP protocol. to request the peer MAC and complete the packaging. That is, this broadcast packet must be sent by each device. That's embarrassing. More than 16 million devices now. In a broadcast domain. That is, in a network segment. You send a broadcast packet. More than 16 million people will receive. We are all obligated to receive and process. Because this is a broadcast packet. I turn on the device and it doesn't do anything. So many messages were sent out. And for the device. Every device has communication needs. Outgoing packets as long as there is a communication requirement. I just turn on the device every day. We'll receive hundreds of thousands of packages. It's too exaggerated. Each device sends a broadcast message. Then deal with. The device freezes when turned on. Because I can't handle it. So you will find. Broadcast message delivery range is too large. It spreads across more than 16 million devices. Once a device sends a broadcast packet. Except this one. All others. Tens of millions of devices will receive. This is really exaggerated. So we have to think. How to solve this problem. Class A address segment is good. Lots of hosts. But use it in network deployment. Obviously it doesn't fit. So all devices are in one network segment. Obviously doesn't work. Then we have to figure it out now. Divide the whole network. It means put a large address range. Divide into multiple small address ranges. Okay. So let's go back to what we just said. Devices on the same network segment can communicate directly. Data from different network segments cannot communicate directly across network segments. It must require other means. Because we send a broadcast packet. Cannot cross network segments. So how do we go about solving this problem? How to divide such a broadcast domain into smaller ones. How to segment network segments. Able to make some broadcast packets. Pass in some cases. This is what we have to think about. Then we need to use a new technology. Subnetting technology. Called VLSM. As the name suggests. The subnet mask can be changed. The way to change is borrow from the network bit to the host bit. Let's take a look at how to borrow. Now the network comes first. Borrow from host. Is the host behind? Borrowing from it means move the network bit back a bit. Move the host back a bit. That's what I mean. This is achieved by controlling the number of network bits. Network bits can be increased. Host bits can be reduced. So this technique is called subnetting. Then once the network bit increases, it means that there are more network segments now. Relatively speaking. Although the number of hosts on the network segment is small. But also in line with our deployment logic. Because in general, in a network segment, there will not be many or even tens of thousands of hosts. This is the case. But it is rare. Because that kind of usually does other strategies alone. After borrowing from a big net, the network can be divided into several small networks. We call this kind of network a small network. Or subnet. Means small. Divide some from the original. So what can be done with such technology? Move back one bit. Equivalent to a more variable range. For example, originally for our